All right, folks, we are on Q4 Extra Credit Part 1. Make sure that we are showing our work on both sides. You are going to need Desmos for this, so I want you to write Desmos at the top of this, okay? All right, please make sure that your volume is up and that you're listening, okay? Please make sure your volume is up and that you're listening. Okay, so we've got all of this stuff here. George and Ramon are in charge of marketing. Each week they decide how much money to spend, blah, 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 blah. I see a table, okay? So when I see a table, let's see what they want us to do with the table. Which of the following values is the best approximation of the linear correlation coefficient? Linear and then correlation coefficient, we have to know that this is our R value. And linear means that I'm going to put this data into Desmos, and I am going to use Y1 approximately equal to MX1 plus B to approximate a linear regression line for this data. Okay, so we're going to let the radio ad budget be X, the sales revenue be Y, and we're going to go into Desmos and we're going to pop this in. So here we go. Let's hope I can share this correctly. Okay, so I'm going to press the plus sign here and get me a table, and I'm going to enter my X values. My Y's. Okay, you want to always double check your numbers, because if any one of these numbers is off, then your correlation coefficient will be wrong and the equation of the line. This says it's linear, so we're going to go ahead and type Y1 approximately equal to MX1 plus B. Notice my ones match the ones in the table. And now it gives us our slope and our y-intercept, but it also gives us our correlation coefficient, which is 0.4146. Now notice, y'all, remember when this is close to 1 or -1, it is a strong correlation. This is 0.41. So the radio ad budget sales versus the sales revenue, the line that this has formed is a very weak model. This line with the slope and the y-intercept is a very weak model. Let's just take a look at this. If you press this plus sign, you can see that these data points are a little bit more spread out. Notice this is in thousands. I mean, they look close to the line, but if you see, this is in thousands. So this is not really a very good correlation between the data points and the line that Desmos formed. That's why this R value, this correlation coefficient, is so low. However, you don't need to worry about that. All you have to do is match the correct answer. Okay, so my correlation coefficient is right here. Please remember, you have got to know this phrase, correlation coefficient. So if you're listening, I want you to write right here, correlation coefficient equals R. Okay. All right, you're going to need to go in Desmos and do this over here. Okay. Problem number 2, looks like we have a sequence, says we have a sequence. Which function can be used to determine the nth term? So basically, what we're going to do is we're going to plug in. First thing we need to do is see if this is linear. I can look at these answers and know it's linear. So we're going to use a sub n equals a sub 1 plus D parentheses n minus 1. I need my common difference. And what I want you to do is draw an arrow here, and I want you to write the phrase common difference here. And then this is my first term, so I want you to write first term right here. Let's find our common difference. So I need to know, how do I get from negative 19 to negative 10, negative 10 to negative 1, negative 1 to 8. The way to do this, if you don't recognize the pattern, is you do the second term minus the first term. And to double check that, let's do the third term minus the second term. Notice I keep getting the same thing, so this is linear, and I am adding 9 each time. I am adding 9, so my common difference is 9. My first term is negative 19. And now I need to simplify this. Notice this format does not look like this. Okay, what they're wanting you to do is pick this answer because you see a negative 19. I want you to write no with an exclamation point right here. Circle this, write no with an exclamation point. This is not your answer. So we are going to bring down our negative 19, and now we're going to distribute. 9 times n is 9n. 9 times negative 1 is negative 9. I'm going to combine like terms. Negative 19 and negative 9 is negative 28. I'm going to bring down my 9n. Notice this is the correct answer. And those of you who understand this, this is the same thing as mx plus b, and we know that our b is our y-intercept. This is our first term. Our y-intercept is actually here before this term. So if you're adding 9, some of y'all know that all you have to do is just subtract 9 to go back. And if I subtract 9, that's when I get negative 28. Okay? Make sure you show your work here for this one here. Okay? If you're listening, I want you to write right above the number 2t. I want you to, let's do a smiley face. Okay? All right, number 3. Which choice lists, and here we go again, correlation coefficients. We have to understand that close to 1, and it doesn't matter if it's negative, so 1 or negative 1, it is strong, okay? Closer to 0 is weak. Okay? So I kind of look at this as dollars. Like, the closer I am to $1, the stronger it is. And sometimes that helps people with the decimals here. So which choice lists strongest to weakest? So strongest would be on this side, weakest would be on this side. Notice both the 1 and the negative 1 are perfect correlations. They are the strongest and they're on both sides, so it can't be A. Okay? Okay, here. These are very strong. They're almost perfect correlations, the 1 and the negative 1. And now let's keep looking. They should be getting weaker at this point. We're going from strong to weak. So 49 cents is weaker than 1, but now it jumps back up to 65 cents. The negatives do not matter. The only thing a negative says is that when this line is drawn, it's going to have a negative slope. But as far as strength goes, this is not in the correct order. Okay, now let's take a look at this. This is perfect. Then we have something like 79 cents, 64 cents, 15 cents, and 0. So this does go from the strongest to the weakest. So the answer is C. We can double check this here. 85 cents, 82 cents, 8 cents, and be very careful. This is not 7 cents. This is 70 cents if you look at it that way. So this jumps back up. So it cannot be this one. The correct answer is C. Okay. All right. All right. Last question. I want you to write right up here, last question, if you're listening. AJ compared. Notice compared. That means there's two functions going on here. This is one of your functions. To the g of x, this is another function. This is given as an equation. This is given as a table, and they're going to do that to you on the EOC. They're going to give you two different ways to represent two different functions and ask you something about them. What are we doing? What is this is a key, sum means add, the slopes. So we need to find the slope. So notice this is in mx plus b form, and m is the slope. So one of my slopes is -4. So I'm just going to come right here and write -4. And then sum means plus. And now I need to find the slope for g of x. Well, how are we going to do that? Notice it's linear. If it's linear, then we can do, and linear means constant slope, so it doesn't matter which two ordered pairs I pick. What I'm going to do is pick the positive numbers because they're easier. Do, down, up, down, up. Okay. We're going to simplify the top. And we get, wait a minute. Yep. We get 12 and it's going to be negative. Sorry. And now simplify the bottom and we get -2. Do that right. Sorry, y'all, losing my mind. 9 minus 21. I'm just going to use the calculator. Yes, -12. My fault. Now, when I simplify this, negative divided by negative is positive. So this is going to be a +6 for this slope. So I'm going to put a 6 here. Sum. I am combining these. Notice one of these is negative, one is positive. I'm technically not adding, I am subtracting, and I get a +2 for a slope. Okay. If you're listening right beside of this, I want you to write linear functions have constant slope. Okay. And then we're going to work out this one. Okay. I believe that's, we got one more. Okay. All right. Oh, this is a great problem, and we haven't done this. Okay. For which positive integer, now integer means like a whole number. A positive integer is the same thing as a whole number, so we're not looking for fractions. Does g of x exceed, that means goes past, f of x? So exceed means goes past or bigger than, okay, f of x. Okay, basically what they're trying to get at is an exponential will always eventually exceed anything else. It will eventually get larger than a quadratic. It will eventually get larger than linear. An exponential grows very quickly. It will eventually exceed all the other functions. They're asking exactly for what integer does that happen. So what we've got to do is we've got to put these in Desmos. We're going to find the intersection, and then the intersection is probably not going to be an integer, and we're going to need to go one past that. So we're going to go to Desmos, and we're going to enter those two functions. Okay, let's clear out the old stuff. Okay, I'm going to enter my two functions. F of x equals x squared plus 5x plus 7. Notice that's a quadratic. Okay, g of x equals 1.5 raised to the x power. That's an exponential, okay? So now what I'm going to do, let me do this deal. And notice I don't like my graph. I can't really see what's going on right around in here. So I need to get rid of a lot of these X's, okay? And let's see. I could try Zoom, okay? I know you guys like Zoom. So let's just do Zoom. Okay. So notice right in here, your exponential is in red. Notice your exponential is smaller here. It's below the black line. Right here is where the change takes place. And now the red line is above the black line. So right after the intersection is where the exponential exceeds the quadratic. Okay, well, the X value is 13.764. I need the whole number integer, and that's going to be 14. It's got to be beyond the 13.7 to put me to where the red line is above the black line. So the correct answer here is going to be 14. Right. So why don't we do this? Let's draw this, okay? And I'm going to want you to draw it over here as well. So let's take one more peek at this. And we want to draw it accurately. So take a look at what's going on here. Okay, we want to draw it accurately. Sorry, didn't do that right. Let's go back and take another look at this. Okay, so right here, we want to be able to draw this accurately. So what we're going to do is we're going to look at that and we're going to draw our quadratic. And then we're going to draw our exponential. And this is what mine looks like. Okay, I want you to notice mine's not sloppy. Here is my quadratic. Here is my exponential. You can put an E here. And right there's my intersection. And my intersection is where X is 13.7 something. And I need to go up, okay? Not because of the 7, but because I need the next integer to where this line is above this line. So that's going to be 14. Okay, I can guarantee you are going to see one of these on the EOC, and we've never done this before. You have to put them both in here and know that exceeds means this, where is this above the other line? Okay. Okay, now what I want you to do over here, you're going to do the same thing, and I want you to draw it again. I want it to be nice and neat where I can see what's going on. Okay. All right. Up here, just write, finally, I'm done. Y'all have a good night.